Welcome everyone to BTT 151, our special video that I'm going to call Series and Parallel Circuits. As I mentioned in my email, my work in Nevada this week, I will not be able to be with you live in our virtual classroom, so I would like you to watch this pre-recorded video that gets into all of the specifics on both series and parallel circuits. Last week, remember, we studied series circuits. This week, we're going to start taking a look at parallel circuits. So what I've done on my dry erase board in my conference room here, I have laid out all of the steps for both a series circuit and a parallel circuit, how we do the evaluation. So I'd like to go through these completely for you. Please review. I think you will find very helpful as you solve circuit problems. So first, we take a look at a series circuit, and remember, symbol for the battery, and I'm going to have circuits that have only two resistors. We're going to label the resistors R1 and R2. So the steps: first, solve for R equivalent, the equivalent value of resistance in a series circuit, R1 plus R2. Next step, step number 2, solve for the current. Current I is going to be equal to the voltage divided by the equivalent resistance. And remember, in a series circuit, the current is the same everywhere. So the same current will flow through R1 as will flow through R2. Next step, step 3. The sum of the voltage drops have to be equal to the supply voltage. So this is represented by the supply voltage V is equal to VR1 plus VR2. So what that means, the voltage drop across resistor 1 plus the voltage drop across resistor 2 has to equal the supply voltage. And then the last step of power supplied and power dissipated that we indicate by P sub S and P sub D. Power supplied is going to be equal to the supply voltage multiplied by the current, and then the power dissipated is going to be equal to the individual powers of each resistor. So in effect, the voltage drop across R1, VR1 multiplied by the current, plus the voltage drop across R2, VR2 multiplied by the current. Add those two powers together, we will get the total power supplied. That's a series circuit. So now in the case of a parallel circuit, I've drawn a parallel circuit again with two resistors, R1 and R2. Note the common connection point that we label a node. So a little bit difference in nomenclature. We will list the current that leaves the positive post of the battery now as I sub T for the total current. What ends up happening in a parallel circuit, that total current I sub T is going to split at the node, and a piece of that current, I1, is going to flow through a resistor, R1. The final piece of that current, I2, is going to flow through a resistor, R2. So again, identical steps. Step 1, R equivalent. For parallel resistors, R equivalent is equal to R1 multiplied by R2 divided by R1 plus R2. Next step, step number 2, solving for the current. I sub T is going to be equal to the total voltage divided by, or I should say the system voltage, divided by the equivalent resistance, Req. Remember, in the case of a parallel circuit, the currents split. So this time, I total is going to be equal to the sum of the branch currents. I1, which flows through resistor 1, plus I2, which flows through resistor 2, is going to equal the total current. Next step, step 3, the voltages are the same. So the supply voltage V is equal to the voltage drop across R1, VR1, is equal to the voltage drop across R2, VR2. And then the last step, step 4, power supplied and power dissipated, they remain exactly the same like we had just seen in a series circuit. P sub S, the power supplied, is equal to the voltage multiplied by the total current. And then P sub D, the power dissipated. We're going to take a look at the individual powers dissipated at each resistor. So the voltage VR1 multiplied by current 1 would give us the power dissipated at resistor 1. That added to VR2, the voltage drop across R2, plus the current I2 through the resistor. Those two powers added together would give us the power dissipated. That number must equal the power supply. So the fundamental things I want you to keep in mind, differences between a series and a parallel circuit. Series circuit, The currents are the same everywhere, but the voltage drops are different. The sum of the voltage drops will add up to be equal to the supply voltage. In the case of a parallel circuit, now the voltages are the same everywhere, so the supply voltage is the same value that would be dropped across resistor R1 and resistor R2. But the currents change. The total current is now going to be equal to the sum of the branch currents. I sub t is equal to I1 plus I2. As I had mentioned last week in our live training, best way to get a handle on series and parallel circuits, solve a lot of problems. And we will see in upcoming weeks where we're going to combine both of these circuits together and take a look at the analysis of what we call a combination circuit, or elements of both a series and parallel circuit, but I'll connect it together. Have a great week. Remember, there is no class on Monday, November 9th. That is a holiday, but I will be back with everyone live Monday, October 16th for in person. Have a great rest of the week. Take care.